Class 11 Mathematics, NCERT New Delhi and COHSEM Manipur. Unit 2 Algebra. Topic Sequence and Series. Subtopic Arithmetic Progression AP. Arithmetic mean AM. Insertion of arithmetic means between two numbers. Exercise 9.2. Arithmetic Progression AP. 1. Arithmetic Progression. A sequence A1, A2, A3, AN, is called an arithmetic sequence or arithmetic progression if A of n plus 1 minus A of n equal to D, where D is constant and n belongs to n. The constant term D is called the common difference of the AP. If A is the first term and D is the common difference of NAP, then the AP is written as A plus T, A plus twice T, A plus n minus 1 times of D, Number 2, general term of NAP. N is equal to A plus n minus 1 times of D. This is called general term of NAP. As giving different values of n, you get different terms of the AP. Some properties of NAP. Number 1. If a constant is added, subtracted to each term of NAP, the resulting sequence is also NAP. Karigumba AP amagi term khudingmakta constant ama hapchinba natraga khaidokpana adumna phangakpa sequence adu through AP oigani. Number 2. If each term of NAP is multiplied or divided by a constant non-zero constant, then the resulting sequence is also an AP. AP amagi term khudingmakta 0 nataba masing amana puriba natraga divide tauba adomna phangakpa sequence adusu AP oigani. Sum to n terms of NAP. Find the sum to n terms of NAP. Let A plus D, A plus twice D, A plus n minus 1 times of D be NAP. Then Sn is equal to A plus D plus A plus twice D plus plus A plus n minus 1 times of D. Also, Sn can be written as this, reversing last term at the first, last second at the second term. First term becomes last term, second term becomes last second term, reversing. Adding, we get twice Sn and A plus of this term. Sum of two first term is twice A plus n minus 1 times of D. Sum of the first two term is also this term. Sum of the last two term is also this twice A plus n minus 1 of D. Therefore, we have n times of twice A plus n minus 1 times of D. Implies Sn is equal to n by 2 times of twice A plus n minus 1 D, which gives the sum to n terms, sum of first n terms of NAP. Arithmetic mean. What is an arithmetic mean? If three numbers are in AP, then the middle number is called NAM between the two numbers. Number ahum AP da lairabadi mayagi number adu topa number ani adugi AM ama kawe. Thus, if small a, capital M, small b are three numbers in AP, then capital M is called NAM between A and the B. Also, M equal to A plus B by 2. Insertion NAM between two numbers A and B. Number A amasung B gi marakta n arithmetic mean fill up to. Let x1, x2, x3, xn be an arithmetic means between A and B. Then A, x1, x2, x3, xn, b are in AP. Using an equal to A plus n minus 1 times of D, we get B last term, which is last term, equal to first term is A plus. How many terms are there? N plus 2 terms. N plus 2 minus 1 times of D, whose common difference is D. Solving d, we get b minus a by n plus 1. After knowing d, therefore x1 is a plus of d, that is d, and x2 is a plus 2 times of d, x3 is a plus 3 times of d, so on xn equal to a plus n times of d, that is b minus a by n plus 1, which are the required AMs between two given numbers a and b. Exercise 9.2. Question number 1. Find the sum of odd integers from 1 to 2001. 1 dagina 2001 phawbagi odd integers sing sum puthu. The odd integers from 1 to 2000 are 1, 3, 5, so on up to 2001. This is an AP. Our first term is 1, last term is 2001. Common difference is 2. Here A is 1, common difference is 2, A and last term is 2001. Therefore, A plus n minus 1 times of D equal to 2001. Giving values of A and D, we can solve n, that is whose value is 1001. Therefore, sum of the odd integers from 1 to 2000 is equal to n by 2, whose value is n is 1001, and twice a is here 1 plus n minus 1 times n is what? 1001. Common difference is 2. We get this. Taking out 2 and cancel, we get 1001 times of 1 plus 1000. That is this into this, whose value is 100200001, which is the required sum. Question number 2. Find the sum of all natural numbers lying between 100 and 1000, which are multiples of 5. 100 amasung 1000 gi marakta leiba natural numbers sing 5 ki multiples sing oiba makoi gi sum puthu u haven. The natural numbers lying between 100 and 1000, which are multiples of 5, are 105, 110, 995. This is an AP. Here A first term is 105, D is 5, and last term AN is 995. Using AN equal to A plus n minus 1 times of D, we get AN is 995, A is 105, N is to be found out, D is giving 5, and dividing 5, and we get this, solving N 179. Therefore, sum to S of 179 is n by 2. N is 179 by 2 times twice A. A is 105 plus n minus 1. That is 179 minus 1 times of D. D is what? 5. Taking 2 and cancel, we get 179 times of 105 plus 989 into 5, whose product is this, and sum up and multiply, we get 98450, which is the required sum. Question number 3. In an AP, the first term is 2 and the sum of the first 5 terms is 1/4 of the next 5 terms. AP amagi first term do 2 ni. Ahanwa term manga gi sum adu aruiba term manga adugi mathangi term manga gi sum gi mari thokpagi amaga manai. So that 20 term is 1 minus 112. Kunsuba term do minus 112 oigani ulo. Here A first term is 2 and sum of the first 5 terms is 1/4 of the next 5 sum of 5 terms. It is given. Therefore, A can be A1 is 2 and A2 is 2 plus D. A3 is A plus twice D. A4 is A plus thrice D. A5 is 2 plus 4D, which is equal to 1/4. A6 is 2 plus 5D. A7 is 2 plus 6D. A8 is 2 plus 7D. A9 is 2 plus ID. A10 is 2 plus 9D. Cross multiply by 4, we get this. And solving from which we can solve D, whose value is minus 6. Therefore, A20 is A plus 20 minus 1D, giving A and D, whose values are 2 and minus 6. And solve, we get minus 112. Hence, the 20 term is 112. Hence on. Question number 4. How many terms of the AP minus 6 minus 11 by 2 minus 5 are needed to give the sum minus 25? For this AP, A is first term whose value is minus 6. The common difference is second term minus first term. We get half. Sn is given as minus 2, 5. Using Sn equal to n by 2 times of twice A plus n minus 1 times of D. Giving the respective value. For Sn, we have to give minus 2, 5. For n, which is to be found out, A is minus 6, D is half, and cross multiplied by 4, we get this, and solve. We get a quadratic equation in L. Factorize and solve n equal to 5 or 20. The required number of terms is either 5 or 20. Question number 5. In an AP, if pth term is 1 by q and qth term is 1 by p, prove that the sum of first pq terms is half times of pq plus 1, where p does not equal to q. Let A equal to first term and D equal to common difference of the AP. Then 1 by q, which is p term. Therefore 1 by q equal to A plus p minus 1D, which is equation 1. And 1 by p, which is qth term of the AP. 1 by p equal to A plus q minus 1 times of D, which is equation 2. Subtracting equation 2 from equation 1, we get 1 by q minus 1 by p. From right side, cancelling A, we get, from this we have to subtract this, whose value is p minus q times of D. This gives D equal to 1 by pq. Equation 1 gives 1 by q equal to A plus p minus 1 D, whose value is 1 by pq. Cross multiply and solve A equal to 1 by pq. Therefore, sum of first pq term is pq by 2 into A, whose value is 1 by pq, plus number of term is pq minus 1 into whose common difference is 1 by pq. We get half times of 2 plus pq minus 1, again half times of pq plus 1, hence proof. If the sum of a certain number of terms of the AP 25, 22, 19, is 116, find the last term. For this AP, A first term is 25, common difference is second term minus first term, that is minus 3. Sn is given as 116. Using Sn equal to n by 2 times of twice A plus n minus 1 times of D, we get Sn is 116. N is to be found out, A is 25, N is to be found out, D is minus 3. Cross multiply by 2 and solve, we get a quadratic equation in N, splitting middle term, and factorize, we get n minus I times of thrice n minus 29 equal to 0. Solving n equal to I, since n equal to 29 by 3 does not contain in N. Therefore, last term is AI, whose value is A plus I minus 1 times of D, giving A 25 and D giving minus 3, and solve, we get 4, which is the I term. Question number 7. Find the sum to n terms of the AP whose k term is 5k plus 1. Here AK is 5k plus 1. Therefore, A1 is 5 into 1 plus 1, that is 6. A2 is 5 into 2 plus 1, that is 11. So on. Therefore, A is A1, whose value is found out, that is 6. And D, whose value is A2 minus A1, giving by A2 minus A1. A2 is 11, A1 is 5. We have known first term and common difference. Therefore, sum to n term, that is Sn, which is n by 2 times of twice A is 6 plus n minus 1 times of D is 5. Giving these values and simplify, we get n times of 5n plus 7 by 2. This is the required sum. Question number 8. If the sum of n terms of NAP is Pn plus Qn square, where P and Q are constants, find the common difference. If the sum of n terms of NAP is Pn plus Qn square, where P and Q are constants, find the common difference. Here Sn is Pn plus Qn square. Therefore S1 is giving n equal to 1, we get P plus Q. For S2 we have to put n equal to 2, that gives twice P plus 4Q. So on. Therefore A is S1 whose value is P plus Q, and A2 is S2 minus A1 whose values are twice P plus 4Q minus P plus Q. We get P plus thrice Q, which is second term. Therefore D common difference is given by A2 minus A1, that is second term minus first one, whose values are given, and solve, we get twice Q, which is the required common difference. 9. The sum of n terms of two arithmetic progressions are in the ratio 5n plus 4 is to 9n plus 6. The sum of n terms of two arithmetic progressions are in the ratio 5n plus 4 is to 9n plus 6. Find the ratio of their ith terms. We have sum of n terms of the first AP divided by sum of n terms of the second AP is equal to 5n plus 4 by 9n plus 6. Then sum of the n terms of the first AP is n by 2 twice x plus n minus 1 d, where x is the first term and d is the common difference of the first AP. For second AP, n by 2 twice y plus n minus 1 times of capital D, which is where y is the first term of the second AP, d is the common difference, capital D is the common difference of the second AP. Cancelling n by 2, we get this, which is equation 1. Therefore n term of the first AP divided by n term of the second AP. N term of the first AP is x plus n minus 1 times of small d, and the n term of the second AP is whose first term is y plus n minus 1 times of its common difference, capital D, and multiply on numerator by 2, we get this, and which can be put in this form. Here twice n minus 1, put n. Therefore if we put this n, we get this. Using 1 we have to we get this. Then giving n whose value is twice n minus 1, we get this. Simplify, we get this, which is the required ratio. Therefore ith term. Therefore ith, put n equal to ith, we get here also put ith, we get this 179 by 321, which is the their ratio of their ith term. Let A equal to first term and D equal to common difference of the AP, but SP equal to SQ it is given, giving their respective values. P by 2 times of twice A plus P minus 1 times of D equal to Q by 2 times of twice A plus Q minus 1 times of D. Cancelling 2, we get this, and evaluate, we get twice A equal to this, which is equation 1. Therefore sum of first PQ term, that is denoted by S of P plus Q, which is equal to P plus Q by 2 twice A plus P plus Q minus 1 times of D, giving twice A whose value is already found out, and D remains unchanged. Evaluate, we get 0, which hence the sum of the first P plus Q term is 0. Question number 11. Sum of the first P, Q, and R terms of NAP are A, B, and C respectively. Prove that this expression. Sum of the first P, Q, and R terms of NAP are A, B, C respectively. Prove that this expression equal to 0. Let x equal to first term and D equal to common difference of the AP. Then A is sum of first P term, that is P by 2 times of twice x plus P minus 1 times of D. Implies on both sides by P, dividing on both sides by P, we get this, and implies A times of Q minus R by P equal to x times of Q minus R plus P minus 1 times of Q minus R times of D by 2. Similarly, we get this 2, and C times of P minus Q by Q equal to x times of P minus Q plus R minus 1 times of P minus Q times of D by 2. We get equation 3. Adding equation 1, equation 2, equation 3, we get left hand side of the we get this expression whose value is found to be 0 after calculation, hence proof. Question number 12. The ratio of the sums of m and n terms of NAP is m square is to n square, so that the ratio of mth and nth term is twice m minus 1 is to twice n minus 1. Let x and y be the first term and common difference of the AP. Then sum of m term is this divided by sum of n term is this, and which is given as m square by n square. Dividing m, and after that we have to cancel 2. We get this, and simplify this. We get this. Therefore, mth term divided by n term is equal to m term is x plus m minus 1 times so y. N term is x plus n minus 1 times so y, whose value is found to be twice m minus 1 by twice n minus 1. Hence proof. 13. If the sum of m terms of NAP is thrice n square plus 5n, and its m term is 164, find the value of m. Here Sn is given as thrice n square plus 5n, and its m term is given as 164. Therefore, S1 is obtained when n is giving 1, we get I. S2 is also obtained when n is given 2, we get 22. S3 is also obtained when n is given 3, we get 42. So on. Therefore, A is S1, whose value is I. A2 is S2 minus S1, whose values are 22 minus I, gives 14. A3 is also S3 minus S2, that is 42 minus 22, that is 20. So on. Therefore, A first term is I, D common difference is given by A2 minus A1, that is A, equal to 14 minus I, that is 6. We have known first term and common difference. After knowing this, since AM is given as 1 by 64, AM is equal to A plus M minus 1 times of D, which is equal to 164, giving A equal to I, and solve we get M equal to 27, hence which is the required value of M. 14. Insert 5 numbers between 8 and 26 such that the resulting sequence is an AP. We have to insert 5 arithmetic means between 8 and 26 so that the resulting is an AP. Let x1, x2, x3, x4, x5 be 5 AMs between 8 and 26. Then 8, x1, x2, x5, 26 are in AP. Using an equal to a plus n minus 1 times of the an is here 26, which is 7 term. A is here 8 and n is giving 7. D remains unchanged. D to be found out. Solve D, we get 3. Therefore, x1 is a plus d, that is 11. x2 is 11, x1 plus d, that is 14. x3 is also x2 plus d, that is 14 plus d, that is 17. x4 is x3 plus d, that is 17 plus 3, that is 20. x5 is x4 plus d, that is 20 plus 3, 23, which are 5 AMs between 8 and 26. Therefore, 5 AMs are 11, 14, 17, 20, 23. Question number 15. If this expression is the AM between A and B, then find the value of N. This is the AM between A and B, then find the value of N. We have this expression is AM between A and B, therefore AM between A and B is given by A plus B by 2. Cross multiply and transfer and factorize, we get this. A minus B never 0, cancel this, the remaining factor equal to 0, and which can be put in the form of A by B whole to the power n minus 1 equal to 0. This gives power n minus 1 should be 0. that gives n equal to 1. Therefore, the required value of n is 1. Number 16. Between 1 and 31, m numbers have been inserted is such a way that the resulting sequence is NAP, and the ratio of 7th and m minus 1 terms is 5:9. Find the value of m. We have to insert m numbers between 1 and 31 so that the resulting sequence is an AP. Also, it is given that 7th and m minus 1 terms is 5:9. Their ratio is also given, that is 5:9. Find the value of m. Let x1, x2, xm be MAMs between 1 and 31. Then x1, x2, xm, 31 are in AP. Using an equal to a plus n minus 1 times of d, we get an is 31, a is 1, n is m plus 2. These are m numbers between these two numbers. Therefore, n should be m plus 2 minus 1 d, from which we have solved 30 by m plus 1. Therefore, a 7th term divided by m minus 1 term, that is given as 5:9. 7th term is 1 plus 7 times of d, and m minus 1 term is 1 plus m minus 1 times of d. Cross multiply and put the value of d, and we get m equal to 14, which is the required value of m. 17. A man starts repaying a loan as first installment of rupees 100. If he increases the installment rupees 5 every month, what amount he will pay in the 20th installment? A man starts repaying a loan as first installment of rupees 100. If he increases the installment rupees 5 every month, what amount he will pay in the 20th installment? Here a is 100, d is 5, n is 30. Using an equal to a plus n minus 1 times of d, we get a 30 whose value is a is 100 plus n is 30 and d is 5. Simplify, we get 245. The man will repay rupees 245 at 30th installment. Question number 18. The difference between any two consecutive interior angles of a polygon is 5 degrees. If the smallest angle is 120 degrees, find the number of sides of the polygon. Here a is 120, d is 5. Let the polygon has n sides. The sum of all angles is n by 2 times of 2 into 120 plus n minus 1 times of 5. All the angles of the sum of all angles is given by n minus 2 times of n minus 2 times of 190. As a polygon having n sides, we can construct n minus 2 triangles, and each triangle has 180 degrees. Therefore, n minus 2 triangles, the sum of all angles is n minus 2 into 180. Cross multiply and solve, we get a quadratic equation in n. Factorize, we get n equal to 9 or 16. Thus, the number of sides of the polygon is 9 or 16. Thank you for watching video.